Hello, good evening everyone. So I think it's already 7:12, so we'll start the session now. So I think yeah, four people have joined the session. So let other join in the meantime. Okay, so if there are any question in between, you can post these questions in this in call messages or chat box. Then I will select the question and answer. Okay. So don't worry if there are any question which you want to ask in between the live class also. So don't hesitate to ask. It should be like an interactive session. It should not be like I am teaching only and you guys are only listening. This is how this session is planned. Okay. So let me introduce this course. Then we will discuss the like recap the previous lectures and then we'll solve the assignments. So yeah, and also this is the last live session of this course, solar energy engineering and technology. So if there are any questions for previous weeks also, so please feel free to ask. Okay. And yeah, there will be a summary session also on Wednesday from 7 to 9. Okay, so that will be a recap type of session where we will discuss the whatever has been taught in this course. Then we'll have an interaction. If there are any questions or anything related to exam which you want to discuss, then we will have the discussion also. Okay. So okay, so I think we should start now. Okay. So, good evening everyone. Once again, welcome you all to this live session of NPTEL Solar Energy Engineering and Technology. This is live session 12 being conducted on 16th of October 2023. This course is taught by Professor Pankaj Kalita and he is professor in IIT Guwahati. I am Rohit. I am PMRS scholar in IIT Bombay. So, I will be taking this live interactive session. So, this session has been planned in such a way like we will have a recap for previous lectures which has been released in this week so that you guys can have a good understanding of the concepts, and then we'll solve some numerical questions like every time you ask for numerical questions. So my focus will be to discuss those theory points which are important for numericals, and then we will move to the numericals and then we will solve the assignment questions. So if there are any question in between, please feel free to ask. Okay. So I think we can start this live session now. So yeah, so before going for this, okay, so let's recap whatever has been taught in the previous session. Okay, so yeah, so basically there has been discussion about emerging cell technologies like perovskite cell, organic cell, dye sensitized cell. Then we have photovoltaic thermal technologies also, and then solar fuel technologies. So basically this is kind of recap slides. So perovskite cell, you remember. So this is the formula of perovskite, CH3NH3PBI3. So an interesting thing about perovskite is that this compound perovskite was generally found in Ural mountain. That mountain is near Russia. Okay, so this was when the research was going on. They found that this can be a good good for producing solar energy through photovoltaic cells. So a lot of research are actually going on for perovskite based solar cells. So yeah, the device structure and all those things. So I don't think I have to go and discuss each and everything. So yeah. So this is actually a very advanced technology, quantum dot solar cells. So a lot of research is also going on. Quantum dots are basically very small size semiconductor materials, very small. So you can see. So basically, I am thinking of having some numerical questions so that can be actually, and this is very important. This can be asked in the exam also. Annual energy potential from solar energy. So it's 23,000 trillion watt year. It's not hour, trillion watt years. And how much is the electricity that India produces? Can any one of you answer? How much is the electricity that India produces? Anyone? Let me see if anyone has answered. Yeah, 400 gigawatt. Yeah, that's correct. 400 gigawatt. Okay, so this is the amount of electricity that it's not amount of electricity that is produced, but it is the capacity. Total capacity installed for electrical power generation is 400 gigawatt. So you can understand how much is the capability of this solar cell. Power through not solar cell, power through solar energy. And how much of this is actually coal power plant? So around 50 60% or 70% comes from coal power plant, more than 70% I think. So yeah, 60% is the installed capacity of coal power plant of the total. I think 75% of the generating capacity is from coal power plant. So around 260 or 280 gigawatt is from coal power plants. Okay. So now you can understand the amount of electricity. Now 23,000 trillion watt years and for so it has been estimated that if we could harness only 2% of this 23,000 trillion watt years of energy, so that is more than enough to power all the houses of the world. So you can imagine the amount of solar energy that we receive. But the main problem is that this is intermittent in nature and not distributed uniformly. Like equator, the people living near equator gets more amount of solar energy rather than people living near the Arctic poles. This is how the distribution is. So that is basically natural distribution. So there are other renewable energy sources also that can also be utilized. So yeah, in 2018 itself, the newly installed renewable power capacity in the world has reached a net of 177 gigawatt. So India itself has crossed the 120 gigawatts of installation. I think more than that. Okay. So these are some of the main technical advantages of this photovoltaic thermal module. So let me check if recording is going on. Yeah, recording is going on swiftly. So, so these are the various design with various efficiencies. So see one more thing you can see if there is honeycombing. Without honeycombing the efficiency is 27%, but with honeycombing 87%. So you can see the like what is the it can be asked in exam also, like what is the benefit of having a honeycomb. Okay. So like the benefit of having a honeycomb is that it provides the increase in surface area actually. So more energy can be actually absorbed or grabbed. So this is basically a PVT collector experimental setup also. So these are some of the instruments that are used for this. Okay, and this is indoor test facility. So this is actually a very important slide. PVT with novel PCM biochar. So basically, it produces biochar that can be utilized for a lot of researches and other applications. Okay. So one thing that can be termed as fuel. This is the important term, fuel. When you understand the word fuel, so it is a broad term, not a very specific term that only refers to fuel for transport electricity, but also feedstock used in the industry is also a fuel. So in like in chemical terms, we can say that something that can burn and produce electricity is called fuel. Like petrol is a fuel, gasoline is a fuel, coal is a fuel. The fuel is actually the thing that is powering the world now. So yeah, solar energy also can be uh, basically can be stored in chemicals through bonds or something. So that chemical fuels can be known as solar fuels. Okay, so yeah, if there are any questions regarding what are solar fuels, so I think most of you have actually a good idea now. So this is what, okay. So like solar electricity can be used to split the water and the hydrogen is stored. So hydrogen, what is the calorific value of hydrogen? 148 or something, 150 megajoule per kg. So this is what the electricity, solar energy is actually used to split the water, and then hydrogen itself has a very good amount of. So that is basically a solar fuel. So that can be used for various purposes like fertilizer, plastic, pharmaceuticals. So this is actually the splitting of hydrogen. It requires it has a Gibbs free energy of 237.2 kilojoule per mole. So this is what it is. So this is the whole thing: water plus carbon dioxide, then oxygen plus fuel. So this is the energy that is provided by the sun to split the water into hydrogen and oxygen. So yeah, there are two methods of water splitting methods. One electrolysis that you know we provide electricity, and then at cathode and anode this other thing photoelectrochemical water splitting. Okay, so this is how it takes place. Photoelectrochemical, just the electricity provided through PV array. Rest everything is almost same. Okay, and yeah, remember this can be a question in exam. Okay, what are the cathode or anode material? So there can be mix and match type question or statement type question. So you people generally ask what is the like what can be question. So this type of question mostly the question asked in the assignment is actually most of them are the question asked in the main exam also. If you have solved the assignment, gone through the lectures, you will be easily to solve them. Okay. So I think you must have remembered the IV curve now, this characteristic curve which is used to determine the efficiency, etc. So these are the challenges: efficiency, durability, very low efficiency, durability is issue because glass components are there. Cost effectiveness. Basically, it is installed in outer environment, so there can be various factors which can hamper its performance. Cost effectiveness is also should be there. So yeah, okay. So I just want you guys to focus on this slide. This was a very good slide which I wanted you guys to actually focus. Yeah, this slide. If please see this slide, how the experimental setup is there and how it is actually utilized to harness the power. So if there are any question, please write in the chat box so that I can see it and answer it. Okay. So I guess you guys must have got a good understanding about this. So let me see if there are any questions. No questions. Okay. So yeah. Oh, let me share the screen also. Okay. So now we will be discussing lecture 33. Okay. So this is very interesting slides. You will see around what is the need. You will learn about more applications of the solar energy, not only electricity generation. Apart from electricity generation, what can be the application? So yeah, there is water crisis. I won't say there is not. So you all know. So how can solar energy be used for this water crisis, solving this water crisis? So like you need to have a good quality water, clean water, which is not saline generally, so that we can drink that water. So there are various water purification method like RO purification, ultraviolet, and several other purification methods. So what are the disadvantages of these methods? So they are very costly and energy intensive, and one more thing is there which is not mentioned here, they waste a lot of amount of water. So solar distillation can be a very useful technology for this. Okay. So yeah, basically a solar distillation can be two types. Okay. So going, this is a solar distillation. So yeah, you have this brine water, then you have the solar. Okay, and then this is how it works. So whatever water evaporates, it gets cooled off by losing heat through convection and QR radiation, and then the clean water is collected here, which is then taken out. Okay. So basically, this is how the solar still works, and this is very important. So one thing you can see the application here. If there is this brine water replaced with sea water, which is actually a brine water solution because of NaCl. So not so brine, but still this can be replaced, and then good quality water, potable water can be obtained from that. So yeah, one more thing is that this water which is collected here is not actually drinkable. Why? Because it is a distilled water now, so it doesn't have any minerals. So this has to be balanced, the minerals has to be balanced for to make it more uh, uh, towards the potable purposes. So these are some of the various resistances, thermal resistances. So I won't go into detail because you guys have must have learned about in the previous lecture slides. Okay, so yeah. So these are performance analysis like hourly distributed per square meter enough from a solar unit. Okay, so these are the thermal efficiency also. So one more thing is that Martin, let in Indian climate output varies from 5 liters meter square per day. So from 1 meter square itself, you can have a harvest of 5 liters of water per day. Okay, so it can be even less than 1 liter in winter. So when if you have 5 liters of water per day, that is a huge amount from 1 meter square. So if you have a 2, 3, 4 meters square, you can easily have manage a family of four for drinking water purposes. Okay, so generally a man or a woman drinks 3 or 3.5 liter waters per day. So you can imagine we have a 3 meter square of this installation, then we it can provide a good amount of potable water. Okay, so there are some influence of design and other things also, design and climatic parameters. So yeah, this slide is very important. So I will leave you guys with this slide for 1 or 2 minutes. So you guys can have a good Okay, so did you guys have any question on that? No questions? Influence of design? Nothing? Okay. So this is actually a box type solar collector in which the rays are actually focused here through mirror, reflector mirrors, and there is a black painted, so much more heat is grabbed that can be used for cooking. So this is the basically a simplest design which is basically used, and cooking period is generally between 11 a.m. and 2 p.m. But there are the inner box area. These are some of the characteristics of these so box type solar cooker. But now more, yeah, this parabolic or circular disc based collector has been used for this cooking pot. So now a lot of advancement has been done. Much more temperature can be achieved, and then cooking can happen at much faster rate. So yeah, you can see food for earlier it was for 4 to 5 people. Now food for 50,000 per day can be actually used. Number of reflectors is 106. So these are called reflectors. There can be a single disk and the reflector. So it can even have a 4,000 kg of steam per day at 180 degrees Celsius per hour. So this is the thermal analysis, solar collector efficiency factor, and all those things. So yeah, now let's discuss this question, and then I will leave you guys with this so that you guys can calculate the time taken for a water of 45 degrees Celsius to boil in a solar cooker with the following efficiency. So alpha T value is given, tau is transmittivity, alpha is absorptivity, F value, F factor is given, overall loss coefficient is given, okay, and then area of AP is given 0.3 and then 6 meter square. Then we have MCW is given 4 into 4190, the mass into specific heat of water. Then TA is given, ambient temperature, water inlet temperature is given, water outlet temperature is steam. Basically, steam, when does steam happens? 100 degrees Celsius, and then this IT radiation is given. Generally, 1000 watt per meter square, it is much lesser than that, but yeah, 1000 watt per meter square is actually given. So now if we have calculate the T naught, that is the time. So basically time, the formula for time is MCW, that is 4 into 4190 upon F dash into AP. AP is 0.3 and then UL. So time taken for this is 9129 seconds. Okay. Now since this is basically transient state type of thing, so time is actually calculated as this minus t naught into ln this upon this, so minus t1 putting all those value, tau alpha value, ul value, tw minus ta value, itt value, so everything, most of the things here. So just you have to put these values. Okay, so similar type of question will be there in the assignment. So I am not going to solve that question because this question is solved here and I want you guys to solve it. You guys generally avoid this type of question because, but these are very simple and straightforward question which can be easily solved. So just try to solve it. If it cannot be solved by yourself, then I will solve it. Okay. So putting all those values, you see how much with easy you can solve. So T naught value is 9129 seconds. So you need to calculate the T, that is time taken for water to reach this. So it's 8365 seconds. That is 139.42. Something around more than 2 hours. Okay. So before going to solar desiccant cooling, I want you guys to focus on this numerical. And if there are any questions, feel free to ask. Okay. Okay, so now you must have got the point now, like the amount of time taken for water to reach the uh, 45 degrees Celsius to 100 degrees Celsius in solar cooker. Okay, so let me see if there are any questions. No questions. Yeah, people are there. Okay, so don't worry. Just keep practicing. These are not very these are not very difficult questions. Okay, so that can easily be solved. Okay, so uh, let me move forward. I think we discussed this. Now this is another thing, solar desiccant cooling. So basically, cooling systems like AC air conditioning type. So we can use solar desiccant also. Desiccant is something that absorbs humidity from the atmosphere. So not atmosphere, anything. So humidity desiccant is something like silica gel is a desiccant. So it can be liquid type or solid type also. So salts are generally liquid desiccants. Okay. So this is how it works. Okay. So air is basically dried when passing through desiccant like silica. Then water is sprayed into the air. As it evaporates, air is cooled and humidified. So that it guarantees optimal interior condition. So basically, aqua ammonia system. This is basically based on the vapor absorption type. So generator is there where the energy can be provided through solar thermal systems. So this is the basically working and different temperature. So yeah, remember these can be very important and can be asked in the assignments as well as final exams also. So it can provide both air conditioning and refrigeration. So anyone of you can answer what is the difference between refrigeration and air conditioning? So yeah, here it's written also refrigeration has lower molecular weight and therefore higher rate of absorption. Absorbent is not toxic and inexpensive. So basically, refrigeration is actually chilling or cooling space. Okay, so taking away heat. Air conditioning is like throwing away air, cool air, with an optimum amount of velocity and humidity. So a lot of factors keep playing in air conditioning. So air conditioning is very much related to comfort, and refrigeration is with cooling or chilling. Okay, so this LIBR is two absorption cooling system. So these are basically vapor type of absorption system combined with solar thermal. So yeah, LIBR installed Ahmedabad. So this is the cost of the plant. That's not for a plant of for 25 tons. The cost is not so high. Yeah, it's a significant amount is solar unit, but this electricity savings and all those things. If you take into account, this will be actually cheaper, and it's environment friendly now. The first thing, solar vapor compression refrigeration cycle. So vapor compression, earlier we have vapor absorption type, then we have vapor compression type also. So this is actually Rankine loop and this refrigeration loop is there. And this one more thing I wanted to say here, this ORC, this is organic uh, fluid type. Okay. Then solar space heating, as you know, solar energy can be used for space heating. Passive solar architecture is there like this, double glazing. Then these can be used in like cold regions like Ladakh, where it can use to keep house warm, and it can also be used for summer ventilation also. Okay, because pressure difference is created as it heats. Then we have solar heating system within liquid flat plate collector, then unglaze transparent collector also like this. And then hot water generation. This is the most common application. Hot water generation is storage tank. You must have gone through or seen somewhat installed on the rooftop. Then parabolic trough collector based storage tank, hot water generation. And liquid temperature power generation cycle using liquid flat plate collectors. Solar thermal water pump. So this is also there. Okay, for solar thermal water pump. So more irrigation is required in summer when solar energy is available. Yeah, intermittent pumping is not causing any difficulty. Excess energy can be stored. Okay, so medium temperature power generation cycle using this is. Can anyone say which type of collector is this? So this is parabolic trough type collector. You can see it. Okay, so this is not parabolic dish. This is trough. No dish is there. It's a trough type collector. Central tower receiver plant which explode for what power electricity generation. Yeah, was these are the limitations of basically a thermomechanical system. Conversion efficiency low, very low, 9 to 18%. Solar collectors are more efficiency expensive than engines. A part of thermal energy loss, a very large area required due to intermittent nature. Storage of thermal energy is also required. So these are the applications. Okay, so I want you guys to see this slide. This is very important. So if there are any question for this slide, please feel free to ask. Okay. So if there are no questions, then we'll move towards solving the assignment questions. Okay, so let me see. No questions. Okay. So yeah, we'll move towards solving the assignment questions now. Okay. So if there are any questions regarding this topic, so please feel free to ask. If there are questions from previous, um, like previous lectures also, so that can also be asked. Okay. So don't worry. Okay. So okay, so now we will discuss the live assignment question types, simple questions. Okay, so if there are any questions from the previous, like the revision lectures we discussed, so please feel free to ask. Okay, you can post your messages here also, so that's not an issue. So let's start now. So the first question is, in paper absorption refrigeration system, heat is rejected in. So first you have to understand what is a vapor absorption refrigeration system. Okay, so let's understand this. In vapor absorption refrigeration system, what happens? So there are two, three circuits. Like there is a generator, there is a absorber, there is a evaporator, and there is a condenser. So condenser is there to reject heat. Okay, evaporator is there to take heat from the stove. Okay, then we have a observer and we have a generator. So one circuit is this. Okay, and one circuit is this liquid ammonia one. Okay, so there is ammonia vapor in the observer. So what happens? Weak ammonia solution comes, then strong solution goes to the generator, then it generates ammonia vapor. Then ammonia vapor goes to condenser, reject heat. This cycle works like this. Okay. So where do you see the heat is getting rejected in vaporization system? Heat is rejected. So here you see heat is getting rejected, and here also heat is getting rejected. Okay. The correct answer is condenser and absorber. If we see the heat is rejected to, if the question is this, heat is rejected to surrounding. If the question is like this, then the correct answer will be this only, not this. If this is there, what? Okay. So now you have to understand this concept, the vapor absorption cycle. This is simple vapor absorption refrigeration system. The components of a dye-sensitized solar cell. So you guys have gone through the, I think in the first or second slide it was there, dye-sensitized solar cell. So basically in dye-sensitized solar cell, semiconductor electrodes and control electrodes, semiconductor will be there in all the solar cells. And basically it's a dye, so dye sensitizer will be there. Okay, compared to your to TCO node is not there, so correct answer is both 1 and 2. So this is basically a dye sensitized solar cell. Okay, so this is the transparent glass cover, this is the TiO2, this is dye basically, the electrolyte is there, counter electrode is there, and there is a transparent glass. Okay, and this is how the electron goes through. Please have a look, and if there are any questions, please feel free to ask. Okay, so if there are no questions, should we go forward? The amount of thermal energy required to change solid to liquid state and vice versa without any change of temperature is termed as. So basically there are two heats, sensible heat, then there is latent heat. This is related to temperature change, related to phase change. Okay, so basically what it's saying, the amount of thermal energy required to change solid to liquid state at a changing phase. And vice versa without any change in temperature. So this is latent heat of fusion. So because it's solid to liquid, then it will do fusion. If it's liquid to vapor, then it will do vaporization. Okay, this will not. So we can see the latent heat of fusion from this graph also. So this is solid, this is sensible heat. Then there is a phase change, this is latent heat. Then this is sensible heat, then this is latent heat. And this is sensible heat. So let's say this is ice. Then it goes up to this 0 degree C and it converts to water. And it go to all through this 100 degree C and converts to steam. So now you got to know about this latent heat and sensible heat. So this is what it is. This is latent heat, this is sensible heat. If there are any questions, please feel free to ask. Okay, now move to the next question. In which of the following vapor absorption refrigeration system the temperature below 0 degrees C can be obtained? So basically it's aqueous ammonia, not lithium. What is there now below 0 degrees C it can't go. So correct answer is aqueous ammonia. Which of the following best describe the working of a solar cooker? So basically in solar cooker there is a concentrated light and then it is converted to heat by focusing it on an absorber or collector area absorber. Then trapping of heat is there, then cooking. So basically it's this.
So let's see an example also. This is the solar cooker. So light is there, it is reflected, absorbed, trapped, and this is the cooking. So if there are anything you want to ask about this, please feel free to ask. Let's move to the next slide. Match the following solar collectors with their output temperature range. So basically the lowest is for flat plate collectors. Basically it will be up to 90 degrees Celsius. Yes, so this is the lowest up to 90. Then you equate it to collector generally 40 to 120. Parabolic trough collectors are generally 50 to 300. Then we have linear phasor reflectors. It is this. And then we have paraboloid base. It can go up to this. The correct answer is D. So this is parabolic trough. So M is given 5 kg. 30-degree oil is also given. Transmitted tau alpha is given 0.8. F is given 0.82. UL is given 6.65. AP is given 0.4. CP is given 4.18. TA is 27 and I is given as 950. TW is 100. So if this much is the so every value is given, you just have to put it in the formula and then calculate. Okay, so first you will have to calculate T naught, then T formula is given, just use it and calculate it. The correct answer is 158 minutes. Okay, so this also I will not solve. Everything is given, the formula is given in the lecture series, just put it in the value and then apply. If it is not solved, then I will solve it. Okay, so the correct answer will be A.2. But this is how it works. Okay, so I think this maybe in pure water or brine like seawater, then it will evaporate, collect it here and collect it here. Okay, so this is how it works. You have to calculate the thermal efficiency, so that comes out to be 14.12. And then the function of solar thermal water pump is to basically to utilize the solar thermal energy for production of power to drive the pump. Okay, so the correct answer is answer D. So this is a solar pump. So this is the solar collector. This is how the solar pump actually works. Okay. see if there are any questions. Uh, okay, so thank you once again for attending this live session. So best of luck for your exams. We'll meet again for the summary session on Wednesday from 7 to 9 p.m. If there are any query, feel free to ask me or you can post it on discussion forum. Thank you.